So now the plan is, yes, we're gonna start lab 6. Also, I think we're doing lab 8 at the moment. So if you have any questions, probably start with the question of Rudy. Rudy showed me that there is something wrong in the lab report. So it's basically my mistake, so we can fix it together. And again, the deadline is on Thursday or not?
Yes, it's on Thursday.
Okay. غير هيك, you guys are good? I never gave you your final grades for the midterm, but I suppose you have them already. So, but eventually at some point I need to confirm to make it official. Okay, do we have anything else to discuss today other than lab 8 and 6? How do we calculate the grade? Isn't your final exam made of 15 questions? I think so. So anyway, I'm gonna say confirm the grades for the midterm. Okay, so I think basically every question is 10 points and you have 15 questions, so the total is 150. But let me check, is it 15 questions or 16? Because I'm not sure anymore. Anything else you want us to do today? Yes, it is 15. So simply divide by 15 to make it out of 10, or 150 times 100. Yeah, okay. Anything else you want us to discuss today? All right, so let me fetch lab 8. I'm looking for lab 8. That should be here. Yes, this is what I sent you with results. All right, so this is solenoid 1. The number of turns is 500. Concerning the length and the current and the inside diameter, outside diameter, this is not gonna change for solenoid 2. So what the mistake we did is the following. So this is solenoid 2. The length is the same. The average diameter is the same. It's only like the number of turns that is different. All right. So for average and length and current, nothing is gonna change. It's okay to call it solenoid 2, and let me say R is equal. What's that? It is R. What did I write in here? Okay, so basically average diameter of solenoid 1. So let me call it diameter. Okay, and this is called diameter. It's only that it is called solenoid 2, but nothing is different except the number of turns. Let me have a quick look. When the X is equal to 10, the magnetic field is 15, and this is half. So yes, I'm right. The number of turns is 500, and here the number of turns is 2000. And probably you want to call it solenoid 1, and please fix that, because I know a lot of students already did the work. It's only that they were confused with this, or probably you did not start yet. So that's why I asked Rudy not to submit, just to make sure he did not misunderstand anything. And Rudy asked me, what do we have to do in the table? We filled the table for you, so nothing is left to do except the fact to fill in the uncertainties on your measurements. What else? And all right, so this is solenoid 2 because I'm using 1000 again. So this is the diameter, not that you need it, but it's okay. Average diameter of the flat coil. All right, this is myself trying to make it nice. Ya Allah, this is so awful. You don't need the average diameter, neither the length. All right, for you not to be confused, I'm gonna upload a new file again. All right, so by the end of this session, while you're signing out, I'm gonna upload this file again. Let me see, did I miss anything else? Solenoid 1, diameter, length, current, and you see they tell you how they measure each. So you can tell the uncertainties. And the uncertainties, this should be the same in the second table. So just make sure, okay? Yes. What else? I think that's it. Yes, that's it. If you encounter any problem, please text me at any moment. All right. Now, let me tackle your questions related to this. Do you think you can do this? Do you have any question? Probably you didn't start yet. It's your turn now to ask me questions. So what is it? Nothing? Let me put the chat on. Probably. How do you calculate them? Oh, okay. I didn't start yet. Okay. Fine. So if you need anything, you email me or send me a WhatsApp. Enjoy Lab 8. Now let us start with Lab 6. I want to show you the manual and the lab report, and you're going to be surprised because the first two sections are really easy. So let me find them. Basically, we have them ready under manual and lab report, but eventually I need to show you I'm going to take the part of the manual, the part of the lab report, and mix them together. This is the lab report. Let me go to Lab 6. Okay, so Lab 6. And you guys, I want you to be aware, I'm gonna show you the plan in a moment, probably when we take a quick break. Okay, this is Lab 6. What does it say? It gives you a reminder about Kirchhoff that I'm gonna revisit later. Okay, now they give you this circuit. Okay, and you have three resistors, R1, R2, and R3. I don't know if the resistors are similar or not, but you will be asked to measure the voltage, the current, and the resistance of each. All right? So let me try to draw what you need to do so I can ask you how to proceed. You are given an ohm meter. I'm gonna call it ohm meter, ohms. You are given a voltmeter. I'm gonna call it volts. Okay, probably draw it here. This is a voltmeter. And you are given an ammeter that I'm gonna draw here, okay? I'm gonna start with a question that you are supposed to answer. Let's say I need to measure resistance of resistor 1. How do I proceed? How do I measure the resistance of resistance 1? And I want you to answer this question. V is equal to Ri is a way to calculate the resistance. I want to measure it with a measuring tool.
I can plot an ohm meter
We get an ohm meter
across R1.
Okay, what do you do with the battery and with the other resistors? Do you keep them?
Doctor, we measure alone the resistor.
Okay, it's important to remove battery. So one, remove battery, because the battery will send a certain signal. It will go into the ohmmeter. The ohmmeter will be destroyed probably if the voltage is high, and the ohmmeter will not give you a right answer because the ohmmeter has its own little battery. It sends a certain voltage and it measures the current to be able to calculate indirectly the resistance. So it's not like it's measuring the resistance, it's calculating. I am lagging, you're saying I'm lagging, so I'm gonna put my camera off for a few minutes. Probably I am lagging, yes. So probably things are gonna be better now. So one, remove the battery, and two, it's very important not to have ORs in parallel. Right, in parallel with your R, which means Ludovic was talking, I suppose. Yes, so if you want to measure the resistance of R1, you can keep R2 next to it, no problem, because it's not in parallel with it. But if it was in parallel, it would be really bad because it would give you R equivalent. All right, Ludovic, can you hear me now? Okay, so it's very important to remove the battery. Now another question, how do you measure the voltage?
We
Yes.
cross a voltmeter across the resistance we want, the resistor we want to نعمل له measure. We plot it in parallel with it.
Okay, exactly what Anthony said. So do we keep the other resistors? Do we keep the battery? Of course, we're gonna keep them. So I'm gonna say close the circuit, close the circuit. Okay, I'll construct the circuit, construct the circuit, and make sure it is closed. It is closed. Plug, I'm gonna say plug the voltmeter in parallel. All right, voltmeter in parallel. Okay, so let me just call them step whatever, and step whatever. And this is it. All right, I know that this sounds so simple to many of you, but believe me, if you are in the lab, a lot of students are very confused between ohmmeter, voltmeter, and ammeter, and they end up mixing everything whatsoever. Now, how do you measure the current? And this is the big deal. Measure I. Sounds easy, I know, and you're gonna now throw me with theories, and it's okay. But I know when you come to the lab, it's gonna be difficult to be done. And by the way, the ammeter has a fuse, and every time you do not put the ammeter in series, you burn the fuse. And every time we have this experiment in the lab, the students end up burning the fuses many, many times on each bench. And all I do is change the fuse. So yes, it's gonna be in series. So the ammeter must be connected in series. And to be honest, if you already have the resistance like that, the resistors, to be able to do a series connection, you're supposed to open the circuit like that. So open the circuit like this. Let's say this is the resistor. You put the resistor like that, and you make sure the leg of the resistor is no more here, it's outside. And then you take your ammeter and you plug it in series with the leg that is up and where it was. You know, this is how we do series connections, because you cannot construct the circuit in series. It's like you have to open the circuit or lift one leg of the resistor and measure between where it is and where it was. All right, I know you will not struggle with this because you will be okay. I will give you the measurements. You will fill in a very simple table. You will measure the voltage of each, the current across each, and the resistance of each. You will be surprised to see that the current is the same. I know this is not a big surprise because you actually know this. And you will also be surprised to see that U1 plus U2 plus U3 is equal to U of the battery, obviously. And that's it for the first section. It's really, really simple. I can show you the lab report in a moment. So imagine you're putting the ammeter here, then here, then here, then here, to end up and see that the current is the same. This is really simple. Now, parallel connection, I'm gonna repeat the whole procedure, probably make sure the procedure is in a certain color, green, for example. All right, so here, be careful, remove each resistor alone from the circuit, remove each resistor alone. Because you don't want to measure R1 while R2 is in parallel with it. For current, you lift the leg of each and you measure in series. For the voltage, you close your circuit, you make sure it's functioning, and then you measure on top of the circuit. I don't like to say in parallel. I usually say on top, because parallel and series means nothing when you have the circuit. On top means on top of the circuit. Okay? And series means break your circuit or lift one leg of the resistor. I think this is the best way to say it. Okay? And here you will be surprised to see that if you add I1 and I2 and I3, you will end up with I4. Okay? And you will be surprised to see that V1 and V2 and V3 are actually equal to V of the battery. That in our case is either two batteries in series or the power supply. Okay? Kirchhoff, I'm gonna take a mini break before I start Kirchhoff. I want us to grab the lab report just to confirm what I just said. I'm gonna move for lab 6, and you see it's really easy lab. So I did not skip it for an important reason. It's only to provide you with a good experimental video. Okay, that's lab 6. All right. Choose 3 resistors. They don't say how, random 3. Plug them as such. Use your DMM, sometimes as an ohm meter, sometimes as a voltmeter, sometimes as an ammeter. Fill in the table. So I'm gonna fill in the table for you. When they say R12, it means the resistance of 1 and 2 together. Definitely in series in the circuit. So you're gonna connect the ammeter to this point and this point, the ohm meter, to be able to measure R12, okay? And when they say V12, you do the same with a voltmeter. For the current, you simply put it next to the object. So I0 means next to the battery. I1 means next to R1. I2 means next to R2. R3 means next to R3. And obviously, they're going to be the same. And then they want you to, all right, when they say specify the polarity of the ammeter, just show, where's the ammeter? This is the ammeter. Just show the plus and the minus. Obviously, the plus is gonna be close to the plus, and the minus is gonna be on the direction of the minus of the battery. So this is gonna be plus, then minus, yeah? Just for you to know how the connections are. Here, طلبوا شيء مني هون؟ لا. So this is the parallel connection, and then you fill in the table. Make sure you fill in the plus and minus. How do you do so? Follow the video, and remember that the 3 measuring tools are digital, so you need only to write the smallest subdivision. Probably you don't need the video. Simply by looking at your values, you can tell the smallest subdivision. All right, based on your experiment, verify Ohm's law for the 2 cases, series and parallel. Take 2 examples for each circuit. You take R2, you take V2, you do the ratio. Do you get I2? You do 2 examples, and then you check it for the series. You take R2 and V2, and you can compare the ratio with I2, and that's Ohm's law. You see? They want you to compare them. Now I'm asking you, how do you compare 2 values that's one is experimental, the other theoretical, and supposedly they should be close? How do you compare them? The question is for you. Percentage difference, I would say, Joe. And how do you find the percentage difference? Let me know if I'm lagging because I turned my camera on. So how do you find the percentage difference or the percentage error? You do absolute value of theoretical minus experimental over theoretical times 100. All right, so the theoretical in this case is the calculated one, and the experimental is what you see in the table. And when they say comment on the sources of errors, can you try to give me 3 sources now during the live session? Now that you know what I did in the experiment, can you name 3 sources of errors? And it's okay if you want to unmute yourself. I would love to hear your voice. جو انت طوشني كل الويك اند وبالليل وبالنهار وكل الجمعة، هلا عامل ميوت. Resistance of the wires, I would say yes. Human error, Anthony, I don't know what you mean. Can you please explain? Joe, you know I'm joking. Keep on sending me as many questions as you have. Yes, the resistance of the wire is actually neglected and it's wrong. I want Anthony to talk about the human error. Where do you see human error? Yes, precision of the measuring tool, because we're using 3 measuring tools in here, the ammeter, the voltmeter, and the ohm meter, the 3 of which have limited precision. Where are we estimating? I'm not doing any estimation. Where am I estimating? So yes, I don't see any human error because the measuring tools are doing the measurements, not me. I'm not doing any estimation. I'm writing everything on the screen of the voltmeter and the ammeter and the ohm meter. estimating the sig fig, I'm actually rounding well when I do the calculation to reduce the error. So there's nothing wrong with that. I'm thinking, you know, sometimes they tell me to write the values of R using the color code, but here they did not. So I cannot see more than 2 sources of errors. Yes, I can only see 2 sources of errors. I cannot see anything else. If you do the temperature of the room, because it affects the flow of the current. Let's say the room temperature is high. I know, yes, it does affect because I'm using copper wires, right? And the resistivity of copper wires is given at 20 degrees C. So if we are in a very cold room, the resistance is gonna change and the current is gonna be affected. But isn't it? Thank you for saying ideal battery. Thank you so much. So let me continue with the temperature. So basically, the resistance of the wire will be affected. So the temperature itself will not create an error unless it's varying throughout the experiment, like it's changing every second. All right, the ammeter, the voltmeter are not precise. We discussed that. Now dealing with the battery, Antonio, I love your idea. The battery is never ideal. You can never find ideal batteries. And if we want to say a V123, which is here, the total voltage, we're supposed to measure it, right? And when we measure the total voltage, are we taking into account that the more current you give, the battery is giving out, the less voltage is gonna be? I don't know. I think we're not taking it into account, which means that, Antonio, this could be a variable. But it's not a variable for a constant circuit. It's a variable, like for example, if you take V123 here to be 3 volts, and you decide to take it again to be 3 volts without measuring it, this is wrong. But since we're measuring all the time, I think ideal battery or not, you're doing the measurement anyway. But anyway, those ideas are very important. So far, we found 2 very good reasons. You can add temperature, although it's not very relevant for this particular procedure. You can add ideal battery or not, but again, it's not very relevant for this particular procedure. Thank you for your ideas. Now I'm going to start with Kirchhoff rules. First of all, it's important for you to take your time to do the connections. So we picked the resistors for you because some students were picking random resistors and it was tough for the measurements. This is one. Another thing, you're supposed to know how to put them, and we did a picture, so this is not a diagram. We showed you a picture of the board. All right, then you have to draw the diagram, and the diagram is in the manual. This is the diagram. Have you ever saw something like that? Can you tell me, is R1 in parallel with R2 or in series? Joe, why can't you say? You cannot confirm. All right, so you guys, basically, guys and girls, because Tiana is with us, so, and you just...
R2 is in parallel with RCD.
So R2
so it's
is...
not...
and why isn't
so
it
R1
parallel with
is
R4? We can call this R, by the way, we can call this R5. All right, so basically we cannot say because R1 would be in parallel with R3 and R5 together. We don't know. R2 parallel with R4 or R5, we don't know. This is basically a complex combination, and usually we call it a bridge. This is a bridge, and sometimes we say the bridge is in equilibrium, and we talk about Wheatstone bridge and many other bridges. So far, let's not call it anything. They're not in series, not in parallel. We're gonna measure R1 alone out of the circuit, R2 alone out of the circuit, R3, R4, R5 out of the circuit. yeah, let's call it, yes, we're gonna use Kirchhoff for this circuit. I'm gonna call it a bridge. It's not series, it's not parallel. Let's not call it complicated. It's basically complex. And then I'm gonna construct the circuit to measure the voltage on top, voltage, voltage, voltage. And then I'm gonna get an ammeter, lift the leg of each resistor, measure the current in series, another ammeter in series, another ammeter in series, and fill in the table where I have the resistance of each. Our total is basically measured between A and B when everything is connected except the battery. And then I'm gonna do voltage 1, 2, 3, 4, all of them, and then V total of the battery, then all the current and I total. Now I have everything I need. Now let me explain what are Kirchhoff's rules. Did you do Kirchhoff's rules in the course? I'm asking if you did Kirchhoff's rules in the course. And your answer is gonna be yes or no. Or I don't know, or maybe. Yes, this rule. Have you ever heard of it? Did you do it in the course? All right, that's good. Have you ever did it in high school? In high school, no. The only students who do Kirchhoff's rules are IB students. Only IB students. And I know you're not, you did not do IB. All right, so yes, you know it from the course. Where is it? That's it? On what? Where's the lab report? They don't ask you to do anything. Make sure you record as well as the current. Okay, there's a missing section. There's a missing section. Is that the lab manual? Okay. Back to the reports. So nothing is missing. It's here. I just panicked for a moment. But what I want us to do, I want us to put the circuit next to us because we need it. Okay? All right. Back to the circuit. I'm talking about this circuit. All right. And probably remove all this. All right. The question is, what do we mean by current flow through node A? So the question is, determine the current flow across the 4 nodes. This is node A. And by current flow, we mean current in minus current out. Okay? I'm gonna do I in into the thing minus I out. All right? Yes, Joe, I know that current in should be equal to current out, but here they want the flow. The flow is in minus out. Okay? So now the question is, I'm gonna keep both. Yeah. So the question is, what do you call, yes, it's gonna be 0 eventually. So this is gonna be 0, but we need to prove it. What do you call the current that is going into A? The current going into A is called I total. And you take it from the table. So you take this value. Okay? It's I total. And the current going out from A are called I1 and I3. And they are, let's call them IAC and IAD. Okay? So IAC and IAD. You see them? So I'm gonna do I total minus this, and check, is it 0? Obviously, you're not gonna get 0. You're going to get a very small value, close to 0, because of the experimental errors. Now you have to do the same for node B, same for node C, and same for node D. It's very easy to look at your circuit, which is here, and to come up with who are the currents going into the node, who are the currents going out of the node, all right? You will have difficulty for C and D because you don't know the direction of the current in R5. You know that the current is flowing in this direction, then in this direction, then in this direction, then in this direction, then here, then here. So you know the flow. So therefore you can tell who's in, who's out. But for R5, you do not know the flow. The best way to be able to measure the flow is to plug an ammeter in series with R5 and to see if the value is positive or negative for you to know if it's going this direction or opposite direction. Okay? Fine? And therefore, since you cannot do the experimental work, I need to tell you if the current in I5 is flowing downward or upward, or from C to D or D to C, all right? We're done with the current flow for Kirchhoff. Now we're gonna do the voltage drop. The voltage drop is a bit tricky, and I'm gonna try to follow the course and probably insert a text box. How do I insert a text box? Insert a text box, text box, all right. When a text box, repeat, insert a text box, okay. All right, can you tell me, I need somebody, since you did it in the course, how do you do the loop for voltage? When do you use plus, when do you use minus? I want you to try, even though I know probably you're not at your best, but I can help you.
We use minus when there's a voltage rise, and we use a plus when there's a voltage drop.
What do you mean by voltage rise, and what do you mean by voltage drop?
Where we're going from negative to positive.
In a battery or in a resistor? Can you show me the difference?
In a battery.
So,
in a resistor بالعكس.
Okay, so we have to follow the direction of the loop. We keep in mind that the loop has a direction. Okay, I will assume you're still beginners, and probably this will help you. So the loop 1, 2, 4, 3. Where is it? 1, 2. So 1, 2, 4, 3 means clockwise. I'm counterclockwise.
Clockwise.
All right. Here, as I go following the current, I have a drop, then increase, increase. So this is negative V1, negative V2, positive V4, positive V3. So in a resistor, if the loop and the current are the same, we say negative. Do you agree? N or 4 for a resistor, if the loop and the current are in the same direction, we use minus. So again, I'm following the loop, minus V1, minus V2, plus V4, plus V3. Do you agree with this? Is this what you did in the course? Is that a yes or a no, or I'm lagging? All right, so basically I'm not contradicting the course. Now let us try an example where you have a battery. So battery, I'm gonna say battery 3, 4. So battery 3, 4. I'm gonna go to this one and I'm gonna remove the loop and pick another loop, battery 3, 4. Battery 3, 4, and come back. This is also clockwise. In a battery, and let me go back to my text box, in a battery, the opposite would happen. Okay? So in a battery, I'm gonna say if the loop and the current are in the same direction, we use plus, because the battery would give you an increase and not a drop. So I'm gonna say U battery, and here drop, drop, plus U battery. So plus U battery minus V3 minus V4 should give me a 0. All right? And if you go back to the table, you are given all the V's that you want, and you just have to add them up and follow plus and minus rules, and you should end up with a 0. All right? Halla, you're too lucky because you are given all the values. Unlike in the course, you use Kirchhoff's rules to find an unknown. In the lab, you are given everything. You only want to check if it's 0. And if it's not 0, obviously you have a mistake. You see what I mean? So you can tell that you have something wrong. Okay? Yes, so that's it for the lab. I'm gonna take the last few minutes to show you the plan for the coming semester. And probably if we have time and I'm not lagging a lot, we can watch the videos quickly. Probably not all the videos. I want you to focus on Physics 201, which is here. We're done with 1, 2, 3, 4, 5. We did not do 6. We're done with 7, 8. Today we did 6, which is great. We're not behind. We still have 9 and 10. Probably I can do them in 1 week. All right. Everything in gray means I did the recordings for you. I'm gonna take in this orange, the recording from someone else. As you can see, you have 2 YouTube, one that would explain how you do the connections and how to do the measurements for voltage, current, and ohms. This one, I would love to watch it. Okay, let's wait for it to open. Where's the file, this one. Yes, so this one actually explains a lot related to Kirchhoff's rules. All right, so we're done with the midterm. We still have the final exam. So that's it.
Measuring the experimental value of the resistance, we'll prepare circuit 1, 3 resistors in series, and circuit 2, 3 resistors in parallel. So circuit 1, 3 resistors in series using the electrical.
Isn't that Dr. Sarah? Do you remember, did you recognize her voice? All right, so I wish I can go fast forward to show you what she's doing.
But circuit board, so this is R1 connected in series to R2 connected to R3. And also in this lab, instead of using a battery, we'll use a power supply. So we have a...
Which means your comment, was it Antonio, about battery and real battery? Who said real battery? Ideal battery, yes, Antonio. So she's using a power supply, which means you cannot use the fact of the ideal battery. This is important.
A direct signal, DC signal. We fix our voltage at 5 volts. This will be V total. Now we will measure V1, V2, and V3, and V equivalent of R1, R2, R2, R3, and R1, R2, and R3. This is a series circuit. So V1 plus V2 plus V3 should...
All right, let me see. She's gonna show you how to do the connections, and they're really easy and interesting to do. I want to show you the bridge, if it's possible. So hopefully she's giving us the measurements while she does the work. I would love to see the measurements from her and not from a different file. What is this? Do you think we can wait for it to load? Probably not. I'm gonna wait a few seconds.
It's a parallel circuit, so V1 should be equal to
So this is the parallel connection. You see how many connecting wires she's using? And this is a lot of errors, right? 1, 2, 3 resistors, and then in parallel with the power supply. So let's see if she has the bridge. No, she's doing the measurements. So the bridge should be the next YouTube, hopefully. I just want you to see it, and then you can watch it later on your own.
Current and Kirchhoff rules. We'll be working also with the circuit board. This lab is divided into 2 parts. In part 1, we will verify Ohm's law, so the relationship between VI and R.
Okay, so she's showing you how to use the ammeter and the voltmeter, and this is really crucial. I like this. But so far, I did not find Kirchhoff, the experiment itself. Now here she's showing you how to do the resistance, how to measure it alone. This is so cool. All right, anyway, I'm gonna watch both videos and make sure if something is missing, because if the Kirchhoff part is missing, probably add a third link to you. All right, and I'm gonna make sure she has some values. If she does have values for us, I really want to use the exact same values in the lab report. It's gonna be really nice, you taking the measurements from the video, but I want to make sure it's gonna happen. And that's it for today. So if you would like to talk about anything, I'm ready. Otherwise, the session is over. Yes? Any comments? The deadline to submit this lab can be next Tuesday or next Wednesday. I will let you know as soon as I upload the work. All right, thank you for today. That's it. Please stay behind if you have any questions.